and it's fantastic to be invited to talk here. Hi, very young students though. Well, you have to start them early with philosophy, of course. So I am not sure exactly what kind of things that you have gone through already. So I was looking, I was thinking very much when I got the invitation how to aim into this topic of philosophy in science and philosophical bias in science. But I decided I want to focus on the broadest possible concept, which I think that you have talked about quite a lot already, which is knowledge. Because if you want to know what is science and how does philosophy influence science, we can just start with how we look at knowledge, because there are at least 3 broad ways to understand knowledge, and I want to show a bit the kind of work that we do by explaining how these different concepts of knowledge would give you different understanding on what's the best science and what's the best type of science and what's the highest form of scientific knowledge that we could ever hope to achieve. Because I mean, when I'm here at the university, of course, I hear all the time people saying, oh, those people are not scientists because they don't use the right methods. Those people there, they don't have a clue because they don't do it in the right way, and they don't focus on, they don't have enough data, they only do qualitative research, that doesn't matter, or they just look at concepts, they do metaphysical speculation. So, I mean, I hear people calling each other idiots a lot. And they don't say it maybe that explicitly, but it's very clear how they think. And now that we live in a world where we really need to have communication between the different disciplines, and also between the sciences and the humanities and the social sciences and the community in general, I mean, it's really problematic that we can't even talk to each other properly. But I mean, there are some good reasons why we cannot do it. And it's also because in our education, we are trained to think in a certain way. And we are told how to understand certain concepts and which theories are good, which methods are the only ones. If you don't use those methods, you don't do science. And of course, there are all these ideas that it's only one science. I mean, this is typical in philosophy. There's only one real science, and it's physics. And it's only one real physics, and it's theoretical physics, and it should preferably be as abstract and incomprehensible as possible, possibly with many, many dimensions that we can never understand. So string theory, for instance, would be fantastic. Quantum physics, which we don't understand, would be fantastic. So you have all these kinds of views about what is good science, what's bad science, what is science, what doesn't count as science. And so that's why when we work in this, when we started this Center for Applied Philosophy of Science, we wanted to actually work on the kind of questions that are relevant for the scientists. Because some people say, well, philosophy of science is not really relevant for anyone except philosophers. And we wanted to actually prove them wrong and say, here are all these problems that you have. They are because of philosophy. It matters to think about philosophy. So what I will talk about today is actually, because I'm working now writing this book that is just called Philosophy of Science. We were hoping it would be called Applied Philosophy of Science, and then we were hoping that it would be called something about philosophical bias and expert disagreement in science. But they only wanted Philosophy of Science, so that's what it's called. But so this is from the first chapter, which is what counts as scientific knowledge, and then scientific in brackets, because if you want to know what counts as scientific knowledge, we have to start with knowledge. So I wonder, have you all heard of Greta Thunberg, the climate activist? Okay, so if you have, that's good. But she's like a teenager activist, and she travels the world And she says, listen to the scientists. Don't listen to me, listen to the scientists. And when she says that, she's talking about how politicians need to listen to scientists because there is very broad scientific consensus that what are the causes and the effects of climate change. So why should we distrust science when almost every single scientist say the same thing? And of course, we are looking to science very often for answers. And now we have all these urgent global challenges like the refugee crisis. We lose biodiversity, we have the pandemic, we have the climate change. I mean, we have all of these things and we're like, okay, where are the scientists? They have to find solutions. And we know that it's not only the natural scientists, and we have seen this with the pandemic. So we were very prepared for developing a vaccine and very unprepared for dealing with every single social aspect of it and the moral aspects of it. I mean, we developed the vaccine and we test it on young and healthy people. And then we start by giving it to all the old and sick people. And then we see what happens. I mean, it's how things are done. And then all these things that we know about how the vaccines are distributed in the world and the patents that so people can keep making money and while others are dying. So there's all these really complicated aspects. So when we look to science for answers and to experts for answers, the most common thing that we're going to find normally is that experts will disagree. So experts disagree on so many different aspects. They disagree. What's the cause? What's the effect? What's the best explanation? How can we make predictions about the future? What kind of models should we use? What kind of factors should we include in those models? What's the most important focus? Is it the money? Is it the education? Is it the environment? I mean, for the environment, this pandemic has been really good. Of course, the climate change is not very good for the for the environment, but during the pandemic, also fewer people died in car accidents, because people were working from home. So it's good for something, bad for other things. So depending on which field you come from, you might evaluate the situation differently. That's why, my university now, they say they want to be a sustainability university and work on sustainability. But everyone here disagrees over what is sustainable. I mean, even within one institute, they disagree. And someone will say, yeah, but that's not economically sustainable. Yeah, but that's not environmentally sustainable. So we can actually publish papers that say opposite things and still claim that they are about sustainability. So all this expert disagreement, it means that we are faced with the problem as outsiders when we're not expert in a field. We have to just think, how are we going to respond to all this expert disagreement? So some people, they just say, scientists and experts know nothing. Don't listen to them. They have no clue. They don't know what they're talking about. And of course, at some points, like when this coronavirus first came, they didn't know what is this virus, but they knew a lot. But just because you disagree, it doesn't mean that you know nothing. So, but that's one response. Okay, so if you have two experts saying opposite things, it means don't look to the experts. So that's one bad response. And another even worse response is to say, I don't think there's a problem in the first place. Are you sure the coronavirus is real? So you have people who deny that there is a pandemic, demonstrating outside of the hospital, saying that the nurses are making up a virus to keep people down. And others are like climate deniers. When people hear about side effects of vaccines, they think, okay, so definitely stay away from all vaccines. They're evil. And so you have this. You have that response as well, which is also very stupid, I would say. So now I'm calling people stupid. This is not a rational response to expert disagreement. And a third type of response is that anyone who opposes the experts are idiots. Okay, so if there is a broad consensus, for instance, about like medicine. In medicine now, we have a lot of very, very good tools. We have so much things that work really, really well. The problem is that if you come with anything critical, if you say that, well, you know, the problem with side effect, it's one of the biggest causes of death in the developed countries, then suddenly you're like, okay, so are you saying you should go back to crystals and healers? And it's like, no, that's not what I say. And if you say something about the climate models that are used, okay, so are you a climate denier? And if you are skeptical of side effects of vaccines, like, yeah, you're anti-vaxxer. And it's been a problem that even public health institutes, they cannot really talk about easily side effects of vaccines because they want people to take their vaccines and they don't want to feed the skeptics. But then the problem is that when you don't give information, just because it's a bit complicated to understand, you feed conspiracy theory because people think we're getting information is being held back. So, okay, so these are like the three types of responses that I just been mentioning here when people hear about disagreement in science. Because, and I think even very highly educated people, they have the third response. So a lot of people doing philosophy of science, they are thought to be against science because we ask questions. So we ask questions about, are you sure that everything can be explained by physics? Are you sure that these are the right models to use? Are you sure that this is what should count as knowledge? And it's like, you are such anti-science. And I think if this is our response, we're not going to learn anything. And so Paul Feyerabend, he is a philosopher of science, and he says we should never silence opposition. I mean, even if people say something really wrong, at least they would challenge you to think harder and make better arguments. So we should never just say, this is the truth, and everyone else keeps quiet. So if you have one theory and one perspective only, that is a problem for knowledge. And we all know how science developed and how everything that we today take for granted in science, it used to be highly, highly controversial and the minority view. So how can we say now that, okay, just because something is the majority view, that everyone is an idiot for saying something else? I mean, so whether you're an idiot for saying something else, I mean, that depends on your arguments and it depends on the knowledge that you have. So we have to remember that sometimes it's the people who are already in an authority position in science who are defining what counts as science. So when, for instance, Einstein and one optician from Iraq 500 years before him introduced the experimental method, then actually that was really controversial because Aristotle didn't use experiments. And no one was allowed to say anything against Aristotle for like so long, for over 1,000 years. He wouldn't be happy. Okay, so that's a problem. We have to think that science moves forward by controversies, by meeting these controversies and disagreement. So what we want in this Center for Applied Philosophy of Science, we want to say that we should have some tools that you could get from philosophy of science to meet expert disagreement in a more rational way, to have better and more rational responses to it. So we want to say that if we have these tools, then we could challenge scientists and researchers and experts and whatever to make their arguments and premises more transparent. Because if you say, okay, if you are one climate expert who says that within 8 years, temperature will rise with 2 degrees if we continue like now, and then another person says a completely different number, then we can only assume that they start from different models and different assumptions. It doesn't mean that just one is right and the other is wrong. It means that, of course, you have to start from some premises. So if they could say, well, given these assumptions, this is what will happen, but given these assumptions, this is what will happen, then you can actually try to find ways to understand what's the difference between these two assumptions. So I will get back to that. So where do our our absolutely deepest assumptions come from in science? They come from our science education, they come from the authorities in the field, they come from what we call the research paradigm that we work within. That's everything you learn when you learn a new topic. So you go into a new field and they tell you, okay, this is our authority, this is the theory, this is the method, this is how we stipulate these various laws, this is our biggest research questions, and these are the types of answers that we're interested in. That's called a scientific paradigm. So in this, when people work within this kind of almost closed framework, we call it like silo research, because you work in a silo where other people work in another silo. And this is a bit like it's in the hospital. I mean, if you have mental illness, you're in this silo. And if you have physical illness, you're in this silo. If you have a heart condition, you're here. If you have like something with your lungs, you're there. But this kind of silo research, it allows that you can be very introvert in your field. So Thomas Kuhn, who came up with this concept of a paradigm, he says that when you work within this kind of narrow framework, then you don't really think that the core assumptions are up for discussion. So for instance, if you have some kind of hypothesis, instead of saying this hypothesis or this theory is something I will investigate, you say, okay, this is how it is. So I think this way of just saying that something is set and it's other things that we should ask about, that's already protecting the core part of the science. So these things are up for discussion, but this here we never even talk about, and we might not even understand that it's there, because we just think, well, if we didn't have it, what would be left of this discipline? So that's why we want to say, if you want to be able to talk to other people and understand where they come from in their field, you need to understand where you self come from. So where did I come from? What did I learn? What was the background for me learning in this particular way? And what are the alternative ways? And what are the strengths and the weaknesses of the different ways? Because if you only know your own way and someone says, shouldn't you get rid of your assumptions? It would be like, yeah, but what should I replace them with? So we think of, for instance, mind and body as separate. I mean, in this Western thinking, that's what we think. And then if someone says, yeah, but you cannot separate a human between like mind, soul, and body. And you say, well, what else should we do? And then you can say, well, here are some other ways of thinking. Either you can take away the soul and the mind and just keep the body and the brain, or you can just ditch the body and keep the soul and the spirit, or you could say that everything comes as a whole. I mean, then you already have some options, and then you can ask, why would anyone accept this or that, or why would anyone reject this or that? And then you can think. So this is why Thomas Kuhn says that when a scientific framework is in crisis, that's when people start asking philosophical questions. Because then someone comes and says, you're a dualist, you believe that the mind and the body is separate. And it's like, I didn't know there was a term for that, but yeah, of course the mind and the body is separate. So then you have to start defending yourself and you hear other sides. So that's why we say, if you want to understand expert disagreements, especially when people come from different backgrounds in research and in society, then you need to know your own background conditions and understand their background conditions and understand what are the rationale for this. Because when people say that you can only use this method, you could only use that method, well, then they think that their own method has only positive sides and no weaknesses, for instance. I see someone has their hand up.
Yeah, I think we can give chance to to some quick questions also in between. Yeah, Janze, please go ahead.
Yes. Hei, Rani. Hvordan går
Hei.
det med deg?
Det går bra.
Det er faktisk en nordmann til i klassen her.
Nej, men fantastisk. Yeah.
Yeah. But I'll keep it in English.
Yeah, okay.
Yeah.
In English.
So I'm sorry, I didn't mean to interrupt you right now, but how do you mentioned something in the beginning, and you probably are going to go into it. I was thinking maybe I'll just ask the question at the end, but how do you imagine that the methodology, which you said in the beginning, methodology of teaching needs to change? At what point are you thinking that is, how early should that happen? Because here I now live in the US, and people talk a lot about how bad education is for children at younger ages. So if we are going to change something at higher levels, usually we always think about how we have to think from the beginning or early on, from the core of how people needs to view, especially when we talk about the overlapping from one field to the other. Like you're saying that there is such a big gap, nobody is able to communicate anymore in different fields. But at what point, how early should we look at, and what are the methodologies that we should apply, in your opinion, to change the way we teach children, for example, at elementary levels? And I think about that because I have kids at that level right now. So, and I'm sorry if I interrupted your talk.
No.
But
And
yeah.
it's actually one of the really important outcomes and very recent outcomes of this this way of talking and this way of working in the Center for Applied Philosophy of Science that we do is that we developed a course, a teaching course, and that's where this book is coming from, that we first started the course. And of course, since I don't work with children, but I work in the university, so what we said here is that if we actually think that our experts can work together towards sustainability, and they won't even understand each other because they use language in different ways, then how do we expect the students to understand anything? Because what we do, we say we have a lot of interdisciplinary courses, but then the students, they are put in the class, and then one day they will have a professor coming from ecology, and the next day from economy, and then one from philosophy or ethics, and then they have, and if people tell them completely opposite things, it's their problem to sort it out. And even I have heard from colleagues who say, no, that's the students' problem. They need to figure out for themselves. But the problem is they cannot even figure out for themselves because they don't even come there and listen to each other. So I think, yeah, if I argue that they should start the second they start university to learn about, I think to learn about the philosophy of science is a good start. And philosophy in general, because the thing about philosophy is that there are no questions that you cannot ask. And the thing about, no matter how much we take for granted, there's nothing that someone hasn't challenged. Even like, do I have a hand in front of me? I mean, do I have a self? Do I have a soul? Does everything have a cause? Does it matter? Even, I mean, do we have to think that we have a history? So I think this is the kind of thing that I want to get into the philosophy of science as well, because philosophy of science is a bit like religion. It's something that you shouldn't touch. You shouldn't question. It's like a very old-fashioned idea of religion. It's something that is given, and you should respect it, and you should keep quiet and listen to what they say. That's a very bad idea of religion, but it's a very authoritative way of thinking of it. But if you say, no, actually people have become scientists because they ask questions, and people before that were philosophers because they asked questions. So if we think, what is science? And we look at the German Wissenschaft, which is very close to the Norwegian Vitenskap, and then you have Latin scienta, and then you have, and now I'm not answering your question anymore, I'm sorry, and episteme in Greek, then all of these mean something with knowledge. So science is about knowledge, and that's one of the biggest questions you can ask. So I want to now say a bit about the three broad types of knowledge that we have in philosophy. So one is the rationalist, the reason. So Plato, for instance, he was a rationalist. And he said the highest form of knowledge is not the particular things and the messy reality where everything is changing that we see around us every day and that we see through our senses, but it's what we can abstract away from that messy reality of, for instance, general hypothesis. So when these things happen, these things tend to happen. Or, for instance, laws. If something is like a universal, abstract, ideal truth, maybe like 2 + 2 is 4. I mean, who can deny it? It's always true. It's never going to change. He thought of geology. He thought of physics, but in physics, even it would be very theoretical physics. So for Plato, mathematics is ideal. So if you think in science, for instance, we would, of course, see all the mess. Everything is different, everything is messy, everything is undergoing change. But we want to have some general knowledge that we can use in different situations, something that is always true. So, for instance, the astronomer Cecilia Pine-Gaposchkin, she found that, for instance, she found evidence that stars are composed primarily of a single element, which is hydrogen. I mean, that's a fantastic kind of insight because it's like the one is one thing and for everything that is a star. And it gave rise to a whole new scientific area, astrophysics. And when we think of Newton's laws, Darwin's theory of evolution, the beautiful thing about it is that it doesn't only apply to cannonballs or to a certain kind of genetic string in the lab. It's something that is universal. Okay, so when you have such universal understanding, then that's a good candidate for science. So we can see immediately that this would work really well with theoretical physics, because in theoretical physics you have these ideal laws. I mean, when you think of law of gravitational attraction, it's not going to predict how actually things fall in this world. Like if I drop these things here, they don't fall in the way that the law predicts. And if you have like a model with more than 2 planets, it's also a problem. So it's like, yeah, we know that the world is messy, but under ideal conditions, it would work in this way. Or in medicine, you can say maybe not under ideal conditions, you can say maybe normal conditions, or if everything else was the same. So what we do if we think in a rationalist way and we want to be science and we know that we're not theoretical physics, then very often we will have to produce this kind of law-like information and knowledge in either a model or in the lab. So Junaid, you worked in the lab, and of course in the lab you cannot allow a lot of temperature changes. You maybe worked, I mean, maybe you didn't even work in the lab, you worked in a model. I mean, because if you work in the lab, there's always things of disturbing elements. So you might want to say, okay, no more lab work for me, it's too messy. I'm going to construct a model and then I can do my work in there. And this is, and when you generate such knowledge, and it is unchanging and it is really ideal and blah, blah, then Nancy Cartwright, who is a philosopher of science, maybe one of the biggest challengers of this rationalist thinking, she has written a book called How the Laws of Physics Lie. She says these laws, yeah, they are universal and true, universally and unchanging and ideal and abstract. They don't apply to reality. And she says, when we do these lab settings and work in these models, we are having this kind of law creating machinery. She called it a nomological machine. We create nomos, laws. And these laws, they are, according to her, artificial. So we do work so hard to create something that could sound as theoretical physics, law of nature, or mathematical truth. So then comes a completely different view on knowledge, which is the empiricists. And the empiricists, empiria, from Greek at least, it means that what you get from experience or observation. So then you say, forget about your mind, the rationality. You can have all these fantastic theories about what's going to happen ideally. But the thing that we are interested in as knowledge is what you have evidence for. And by evidence, we mean you have seen it with your own eyes, for instance. So you have seen it through your senses. So you need data. Theories, they are speculative. Data, they are true. So then you have all these sciences that say you need more data. If only we had more data, then we would know everything. So the idea there is that we have no knowledge before we have started using our senses. So when we're born as blank slates, empty buckets. And this is also one way actually about the question of teaching, that very many people think of education as filling up the bucket. So if I just give you enough facts about the world, you will be educated by the end. And this is something you hear from people saying things like, well, there's no way you can go to college or to school without having read this or known this or heard about this. That's this way of thinking. It's not about how you, like, what you do with the knowledge, how you learn to think, how you learn to meet new knowledge, how you learn to be creative, critical. I mean, it's so this filling up the bucket with data, these types of sciences tend to focus very, very much on just gathering information and doing experimentation, for instance. So observation, experimentation, but be very, very careful to suggest explanations, because you can observe some interesting correlation. For instance, you can see that, oh, it seems like we have a correlation here between when people use a mask and then the virus spreads less. And someone can say, oh, but that's not real evidence. You need to use the right methods to find that. So you need to do it in a certain way. So there could be many, many explanations. So when you also see that fewer people die in car accidents during the pandemic, that doesn't mean that the virus is good for you, for instance. So this kind of thinking where you look at the data, then you have to be careful to speculate about why do we see these things happening. So there's something called logical positivists. So this is like how Western philosophy really influenced science, I would say, in a negative way. But because the logical empiricists and logical positivists, they said there's just two types of knowledge. It's what you get from logic and what you get from the empirical side. So logic, that's like mathematics. And then you have the empirical, and that's science. And it means that science should only deal with the empirical, which means that if you think anything about metaphysical speculation or philosophical speculation, that has nothing to do with science. And if you have anything about morality, what's good or bad, then that has nothing to do with science. So science, facts on one side, that's the realm of science. And what is good, that's for politics and ethics. That's something completely different. So, and then of course, now today, when we say that science should be responsible and sustainable, it seems that we want something ethical from science, but then many scientists says, not my responsibility. I just figure out the facts, you figure out what to do with it. So that's like a very strict empiricist way of thinking of science. So we can see there that if you think in this way, then, I mean, of course, you would never say philosophy is going to be included in what you're interested in science, and of course not religion. So those will be not very good sciences. And if you think in the rationalist way, then of course everything like social anthropology and history is never going to be something that gives you universal truths. It's going to follow certain historical and contextual events. So you see how they would emphasize different things. So I think in for instance, biology and in chemistry, there will be a very clear divide between people who are more interested in theory and models and people who are more interested in pure data. So, and sometimes, of course, the models just have the data, so then everyone can be happy, but there will always be these tensions. Okay, so the final one I would mention here is what I have started to call just perspectivism. So that's the more Kantian view, Junaid. So perspectivism is neither strictly rationalist, it's not all about reason and thinking, an abstract ideal, and it's not purely empiricist. They don't believe that you have pure data ever in your knowledge. So the idea here is that there is no objective view from nowhere. There is no God's view in science. None of us will ever be able to represent God, the God view. So Donna Haraway, she's a feminist philosopher of science, and she calls it the God trick. She says scientists, they pretend that they have this view from nowhere, that they can see everything in a purely neutral way. And this is, of course, the empiricist ideal, because they think that your data, your sense data in some way, that they are pure and uninterpreted. And in the perspectivist tradition, they would say that, no, you always start from somewhere. When you see something, you already see it as something depending on where you come from. And depending on, so this is different views in perspectivism. Perspectivism is something that, for instance, when I lived in UK, people were not very happy with anything that had to do with perspectivism in philosophy, because they wanted to have proper knowledge about the real world. They don't want us to get in the way. But then the perspectivist is going to say that, well, the empiricists, they pretend that they're not there, but they are there. So that's a problem. So for a perspectivist, you can have two experts looking at the same thing and see two different things. So have you ever seen this duck rabbit figure where there's something that can look like a duck or it can look like a rabbit, but it's the same figure? Have you seen it? Junaid, maybe you want to share it if we have. Yeah.
Yes, I have, and I think the students can relate to that because we discussed that special theory of relativity. So they very well know the perspectives.
Yes,
the
very
idea
good.
of different perspectives.
Yeah, so that's the thing. So then you would say that, okay, if you start from the assumption this is a duck, that's going to give you entirely different theories about what this thing can do than if you start from the idea that it's a rabbit. So, and if we think in science, then for instance, the concept of genes is something we think is just one thing. But then there was a woman in her master's studies, she did a check just in media to see how science education was talking about, science communication were talking about genes, and she found at least 19 different ways to explain what is a gene. And they were quite radical. So some would say it's a molecule, someone would talk about it in the functional way, it's what brings the inheritance, inherit the feature, the traits, and some, yeah, so it was just very different ways to talk about the same thing. So it really matters that we have these theoretical concepts, and these theoretical concepts is not something that we can get rid of. So the theoretical concepts and the theories and perspectives that you have, that's going to matter. So for instance, Immanuel Kant, when he talked about perspective, he talked about the human perspective. It's what we all bring with us as humans. For instance, unlike a dog, I can't hear all these sounds that are around here. And I cannot smell everything that my dog can smell. And he cannot see everything that I can see because he cannot see all the colors. So there's something for all humans that makes us see in the same way. But then some people have said, actually, you should be more radical. We need to be more radical about this because there might be differences. For instance, if you're taught within a paradigm, then you learn to see in a particular way. When you look into a microscope, you have been taught what to look for in that microscope. If I look in a microscope, I see nothing, maybe dots if I'm lucky, but I'm not going to see anything because I haven't learned what to see. So you have to think that you learn how to see, not only because you're born as a human, but because you're raised within a way of thinking in science. So some people are going to say, okay, one way to understand perspectivism in science is what all scientists, any scientific community would agree with. We use methods, we use tools, we have these procedures and we call them science. And others say no, like Thomas Kuhn, no, you have all these different paradigms, they see in different ways. So there will be the society, this small community is deciding what is the right knowledge and how to see things. And then some people say, but who are these scientists? Because a lot of science is just a very minority group in the world. It's people who are rich, educated, a lot of white people are represented in science, a lot of men, a lot of people from a certain class, and we lack a lot of voices and perspectives in science. So there was this movement in the late 60s that started a completely different turn in philosophy of science, that started with the feminists who said, well, first of all, half of the human population is not part of science. And then they said, but it's much more because you have all the people who are poor, you have all the people who are, I mean, and then they started talking about this, okay, ethnicity and also religion, and also gender orientation is now a big thing. So it's like all of these different minorities in society, if they are not represented in science, then we miss a lot of problems for science to solve. So who decides what's the scientific problem? But one thing that Sandra Harding said, she said in an interview that people say they care so much about sustainable environments, but if people really cared about sustainable environments, we would have it a long time ago. Instead, we have very, very advanced pieces of weaponry. And we have very, very powerful computers. Someone is deciding this is a good problem, this is a bad problem, this is something we care about. She says there's a lot of tropical illnesses we know nothing about because there are no scientists who think this is a problem. So because it doesn't hit the authorities, those who have power in society. So she says if there is power imbalance globally or within a society, then that is a democratic problem when it comes to scientific perspective. For instance, if you're in a wheelchair, the challenges in the world are going to be very different for you than for someone who can walk freely. The idea that we need actually to discover knowledge gaps. So of course, we care about the coronavirus a lot because it came to the West. If it had stayed in the East, I don't think as many scientists in the West would have mobilized. I mean, it comes here and it becomes a problem for us here. So then we start putting in all resources to solve it really, really quickly. And this is what the feminist philosophers of science say as well. And for instance, a lot of philosophers in medicine say, we don't have knowledge about the female body, for instance. We have a reference man that is a white man who is 25 to 30 years old, and he is 170 high, and he weighs, I don't remember how many kilos, but this is the medical reference man. And any kind of dose for a medicine is calculated according to that body. And any kind of side effect is tested for that type of person. So this reference man, that's what we also have a lot of in science. And in psychology, for instance, they found that so much of the psychology data that we had in psychological research were gained from American universities on their students. So then they said it's these weird samples. It's like Western, educated, industrialized, developed, rich, developed. Yes, weird. So who do they really represent? So that's why now it's been a much bigger move in science towards having talking about epistemic injustice. So we have a lot of knowledge for a certain type of people and for a certain type of problems that those people care about. And then there's a lot of knowledge that we lack that could have been relevant scientific knowledge. So what Sandra Harding says, she says, whenever we look at the question, is this a good solution? Is this a sustainable solution in science? We should say, who pays for this research? Who benefits from this research? And who pays the cost of this research? So for instance, in Norway now, everyone who buys a new car, they buy an electric car. But resource extraction of lithium that you need in the batteries really damages areas in South America, for instance, huge areas. It requires so much water to extract. So it's very sustainable here for us. We have very nice smell around in the city now, everyone driving electric cars, but it's really bad elsewhere. So, I mean, a lot of technological innovations give us sustainability for a certain group of people, for a certain community in a certain time, but not for other people elsewhere and such and such. So when people say that knowledge is purely empirical, it's all about the facts. It's nothing to do with values. It's nothing to do with ethics or morals. Then the problem is that why do we do science? We do science because we want to develop technologies, innovations, improve our lives. But whose lives are improved? And what technologies do we develop? So we were talking to one guy who is a sociologist in the UK, and he had been working with engineers who were going to develop these artificial intelligence little things for taking care of old people in their homes, so that they could chat to their little technical thing and get stuff done and be safe. And he said, as a sociologist, he was the only one who asked, how will this affect their lives? And what are they missing out on because they get this technology? While he said the engineers, they only were concerned with whether it worked the way it was supposed to work technically. So it just shows that these kind of perspectives, if you want to have these kinds of other types of social, moral, philosophical type of debates in science, which I think we should have, then you need to include people and perspectives from other disciplines, from the humanities, from the social sciences, and you need to look at all these, because everything is going to be good for something and bad for something. And it's never easy to just say, okay, it's good for something, so let's do it. And then 10 years later, you see all the bad effects of it. So it's a good thing if you have many perspectives who will see different things, because someone can say, yeah, this is a good idea for that effect, but what about all these other things that might happen? So you see, this is why we really, really need this transdisciplinary communication, where so people in philosophy of science who are interested in this injustice about knowledge, they say, we cannot just keep talking experts between ourselves. We need to include local communities where people are affected by the science and the technology. And we need to get their inputs as well. And there's a lot of knowledge and a lot of expertise that people get from being a practitioner without being a scientist, because they work every day within an area and they see the impacts and they see the changes and they see the shortcomings. And that's really valuable information and knowledge too that we need to consider. So this kind of, so the perspectivists, they go from this very broad human perspective to very much a more relativistic idea that you could say any knowledge is relative to which perspective you have. But I think many people in the perspectivist tradition, they want to say that we need to listen to more perspectives. And this is what, for instance, Hannah Arendt said. She says, this is the fabric of humanity, that people have different life stories, they have different perspectives, they have different views, and all of those stories are part of the truth. So what you have experienced in your life, that's part of the truth, and we need to listen to it. We cannot just say that, okay, these are the stories we will listen to and these stories we won't listen to, which is very typical the case of minorities, for instance, that we don't, and marginalized groups, we don't listen to them. So she was also interested in for instance, stateless people who don't have anything to say in society. Okay, let's see, blah, blah, blah. So perspectivism, that's much more common in the social sciences, of course, and in the humanities. So in social sciences, I think most people would consider a colleague very naive if they said that they were strict empiricists who believe that you have neutral, objective, God view data. So that's when people start calling each other idiots. So you see, they would call the sociologists and social scientists idiots because they think that knowledge is relative, there is no true knowledge. And the others would say that they are naive because they think there is like one single perspective that is the true one, which is not, it's not distorted by anything. And then of course you have the rationalists who do their own thing in the lab, in the models, and so yeah. So that's why we say, if you don't, I mean, even if scientists don't really engage very much with philosophical debate about knowledge, or philosophy of theory, method, practice, they don't necessarily ask these questions. They have already sided with the position. And to be aware of the fact that you have sided with the position should be important information for everyone. And then if you learn about philosophy, you learn about philosophy of science, and you can become aware of the alternative perspectives, the strengths and weaknesses of these perspectives. Then maybe you can also understand better what the norms that you take for granted in your field, where they come from, and then norms that other people take for granted in their field, that they are also rational ways of thinking scientifically. So, and I think only then can we stop going into each other's classroom and telling the students things and go back. And then, I mean, because if we want to really teach students from different perspectives, then at least the least we can do is to stay there and listen to the others at the same time and try to understand where they come from. We cannot just leave that to the poor students. Okay. Yes, that's what I wanted to say. That took almost an hour though.
No, that was excellent, really, and I think that has paved the way to what I would, teach in the course. Now we have a clear beginning. Now we can build upon this. This actually, Rani is here as a guest lecturer. It's this lecture, in fact, is part of a series of lectures, or a course designed by Al-mawrid for young theologians to familiarize them with science, with philosophy, with especially with the problems that science poses for the question of the existence of God and so on. So I think we can, before I ask my questions, we can take a question from Salman Tahir, because that's really related to what Rani has been speaking about, perspectivism. So Salman Tahir, would you please put your question yourself? I mean, you can read it out what you have written, or maybe we can try reading it out. If you can't, just let us know.
Thank you so much.
Yeah, please go
yeah,
ahead.
so just wanted to ask this perspectivism point of view, very interesting to hear about it. Just wanted to understand that, if we start accepting multiple perspectives related to a certain problem, how do we determine the applicability across the board? And how do we select good theories from bad theories? Because eventually, as far as I understand, one of the purposes of studying science is to be able to predict future or solve specific problems. So how do we judge for these theories for their predictability? What criteria do we use to select which one is closer to the truths that we want to arrive at?
Yeah, no, that's because what the perspectivists are saying is that it matters where you come from, what you assume, and what you have learned, and what are your premises, and you cannot get rid of those premises. So what the perspectivist is going to say, they're going to say that if you believe that your view is objective, it's probably because you belong to the majority view. It's because you belong to the dominant view in science. Only then can you believe that your view represents everyone. A different take is from Nancy Cartwright, who says that because we know that for any set of empirical data, there are infinitely many theories that could explain them. So how do we choose between these explanations? And some people will say what you say. They say, ditch the explanation, focus on prediction. For instance, in machine learning, you gather lots and lots of data, you put lots and lots of data into the machines. Of course, then you put in a lot of assumptions about determinism and raw data and all of that. And then you run the program and you see how often is this model able to give the right prediction. And those who are ready, who can give the right predictions the most, that's the best hypothesis. But from a rationalist perspective, Aristotle used to be right in all his predictions. I mean, everything that we see in this world fits Aristotle's physics much, much better than Newtonian physics or Einstein's physics. So if we're going to say, well, they predict what's going to happen, then Aristotle was always right. So why on earth would we move away from it? So, I mean, in that sense, I think we need, so what Nancy Cartwright says, she says, we need to think about science as something that isn't easily proven true. That many people have said that, but we should think about what's a reliable scientific theory. And she says one thing that makes a scientific reliable is that many different types of researchers focusing on different parts and aspects of reality, that they have arrived at the same conclusions. So for instance, she says climate change, that climate change is human-made, is something that they see in that many, many different research groups have found pieces of evidence for. So whether you work with glaciers, or whether you work with weather models, or you work in marine ecosystems, so all these people, they haven't come together and decided on one paradigm and one answer. They have done their separate things, and they have come to the same types of conclusions. So that's one way to say all these different perspectives, it still fits this type of conclusion. Yeah.
So what comes to my mind is also Darwinian evolution. I mean, the data comes from so many different fields. Comparative anatomy comes from genetics and carbon dating and so on, and they all converge toward this theory. So
but then there are also alternative theories that also explain evolution, but not like Darwin. So so evolution is one thing, but Darwin's theory is Darwin's explanation is not something that we should think is the only way to explain it. So there are other also ideas that focus much more on environment and the interaction between the organism and environment. And Darwin, he focused on luck and unluck and accidental. Right. Yeah.
And nowadays we, how we see it is that we take Darwinian evolution as an umbrella term and try to put everything under that. And what you are saying is also completely valid. Like Darwin's view was here, and there are so many other things that we are now incorporating under the name of Darwin, which were not, for example, genetics were not known in his time. So yeah. So that's right. But that's a very good, that's a very good answer, by the way. You connected it to Nancy Cartwright, and to have different fields in mind, and then they converging toward one thing that gives more validity rather than only one field.
And but Nancy Cartwright also thinks that science is over focusing on generalities and focusing too little on local application. Yeah. That's something I'm very I agree with her very much in that. For instance, in medicine, you can say that for a normal person who doesn't exist, it should always work like that, which you cannot know. And then instead of thinking, okay, is this a good medication for you? Because if you have an allergy for one of the components in a vaccine, you shouldn't take that vaccine. You should take this one instead. If you get very bad side effects from this because of some property in you, or you don't have the biological receptor to be treated by this medicine, you should get this other one that you are a good candidate for. So in the same way, she would say climate models, they need to be, for instance, locally adapted. You cannot have like one climate model for the whole of the world.
Hi, thank you very much, Rani. That was very interesting discussion. But I was just wondering, because you did mention that you didn't mention the issue of representation, right? The difficulty that I see is that, yeah, we approach science in a way where we tend to assume that it does not have any biases. It's coming from this pure perspective. It's not overloaded with anything else, and it's just going after data, and data is the only decision maker. But behind the scenes, of course, data is often being selected unconsciously by people first, simply because of their background. But the danger here is that if we kind of scandalize science too much, or if we raise too much skepticism due to these kind of, I would say, political factors rather than kind of, well, not even methodological. I mean, I would say the way we are kind of approaching the process of science. So it can make practical decision making and moving science forward very, very difficult. I mean, the issue of climate change that you were talking about, for decades, people have not been able to show that the dangers of tobacco and it causing cancer. Pretty much anything can be politicized, and then science is unable to do anything simply because there's too much skepticism, there's too much debate, doubt from different political angles. So what practical kind of way through this do you see? Otherwise, it'll just be, this is my perspective, that is your perspective.
Well, I think until now, it's been exactly like that. We just pretend that these other people don't exist, that their problems aren't real, that these bad side effects of science aren't important because we don't notice them. We don't, people cannot prove because no one has turned it into science, for instance. So for instance, if you get a new medication and you feel really, really ill, and then you go to the pharmacy and you say, I feel really ill from this new medication, then they will look at the bottle and they will look at the label and it will say, I don't see this side effect on the label, so it cannot be this drug. So that means that your data doesn't count as scientific data because you're not in a trial. You're just an anecdote. And a lot of knowledge are these kinds of anecdotes. And medical science, which is really, I think, which is really shocking to me, is that in randomized controlled trials, when they test medications, most people are not eligible for participation. So it means that most people get excluded from the trials because they either have too complex problems or too many types of medical medicines that they use at the same time, or they are too vulnerable to side effects, or they are, there could be various things. They're too young, they're too old, they are a risk group, for instance, which means that you don't generate scientific data from this group. And this is how we got the scandal with the thalidomide case, where pregnant women who took a medication that was considered completely harmless, that they had children that were born without limbs. And it took a long time before the scientific reason for this was uncovered. But it started with anecdotes from the local populations, from the doctors who discovered this in their practice. And they said, this is not a very common thing that happens, that people are born without limbs. The only thing we can see in common is that the mothers have been using this drug. And then what they did in society, they took away that drug immediately from the market. And after that, they started doing the scientific research on why and how can this actually affect people. So just because the reason why you take it off, or you say that something is a problem, is not scientifically generated in the first place, doesn't mean that you cannot turn it into science if you care enough. I mean, what has happened with pregnant women is that no drug is ever tested on pregnant women. So if a woman gets pregnant, you take away all her drugs. You say you cannot take any of your drugs, even if it's about your life, because you can harm the fetus. So it means that we lack a lot of scientific knowledge about pregnant women. So pregnant women, they say, we want to be part of medical trials because I need my medications to stay alive, or to stay mentally ill, or to stay whatever. So please include us in your trials. But you cannot, for ethical reasons, include them. But then you have, for ethical reasons, you have to exclude them also from using the medication. So yeah, we can pretend that there is no variety that is scientifically relevant, and this is what we do. But then to say, just because we pretend it isn't there, we shouldn't think that, and there's nothing to know, because there's always more to know. So how do we deal with it? It's always more to know about the limitations of our own knowledge as well. You need to know your unknowns.
Yeah, can I say, can I put it like this, that the process of doing science is imperfect, and it has all these additional factors involved. And it, like the book Structure of Scientific Revolution by Thomas Kuhn, which also shows that it kind of develops in cycles, and counter examples develop, and they are noticed, and then changes come in later. So should we approach it like that, this is an imperfect thing that is moving forward with the limitations?
Rani, actually, I also share the same feeling broadly with Raza. The point he's making is because we live in the West and we don't see it, but in the East, especially if you go into the subcontinent, there's a lot of science bashing because of so many reasons. So I think he's fearing this, that it might be, I mean, we might be fueling more to that. Actually, what you said in the beginning of your lecture was exactly what he's saying right now. So yeah, that's a little bit more background.
I mean, what I said in the beginning is that it's not a good response to pointing at challenges in science and things that we should be aware of in science to say that don't feed the extreme people. So don't talk about side effects of vaccines because you don't want to feed the anti-vaxxers. That's not a good response. What would be a better response is that we should include more types of scientists. We should include a bigger range of people in the sciences. We should include people from more types of disciplines working together when we develop science and technology. If we had people from social sciences working in the medical faculty or medical school, they would be able to tell you that, okay, have you represented these types of bodies, these types of people, or these types of groups? Because they might not be the same. I mean, so I know a lot about side effects of drugs because I've been working with Uppsala Monitoring Center for Drug Safety the last 3 years. And one of the stories they tell is, for instance, a malaria medicine that was developed and that worked brilliantly, but it killed a lot of Africans because they had a genetic variation that the Englishmen didn't have. So it worked really well on the British people going to Africa, but it was very, very bad for the Africans. So if you take the African perspective, the African lives, and you take that as the default of scientific knowledge and issues and problems, you would have a very different type of medical knowledge. So that would show the kind of, so the perspective, it doesn't mean that, okay, it's a relativist, I think this is true and you think that is true. No, actually, this happened for me. These are challenges in my life. Yeah, but I don't see those challenges. I don't sit in a wheelchair. I don't have to care about that. That's just something for special interest people. Okay, I'm not blind. I don't have to care about your life experience and technology for you because you're a minority. That's a problem if science becomes blinded by an elitist and a very small power group of perspectives.
Rani, we can put it in a nutshell that the whole exercise has to do with including more people, being more exclusive, including more perspectives, and to give an impetus to improve our methods, right?
Yeah, but also this is the perspectivist view. So what I'm telling you is that the perspectivist view, this is what the perspectivist view would answer. The empiricist is going to say, of course,
we empiricists
none of this would none of this matters, because if you stick with the facts, it just means that we didn't have all the facts. We need more facts. That's what the empiricist is going to say.
Yeah, no, we would say that psychology is not a science, it's nonsense.
Yeah. So that's what you you say. Politics, social science, feminism, that's one thing. Exactly. But yeah, there is more data to gather. Let's gather data from women. Let's gather data from pregnant women. Let's gather data from poor people. That would be the empiricist answer. And the rationalist would say, it should be the same for everyone. If you had a twin that was exactly like you, then the same would happen for them, or under ideal conditions.
Now we can take the next question.
Rani, sorry, I give very long answers.
No, that's really helpful. That's where we get to understand things. So we have 5 minutes. Abdul Khan Sahib, if you can please go ahead.
Yeah, I have a short question and a short comment, if there is time. My question was that Dr. Anjum spoke about silo research, probably alluding to specializations and things of that nature, where each one is not able to talk to the other. In the past couple of decades, there has been an effort towards what is called integration of knowledge, where you should be able to connect various platforms of knowledge. My question is, what is, in your opinion, the prognosis of this effect and of this effort, and how far do you think it will go? If I have time, I'll make the comment also.
Yeah, make the comment also.
Oh no, this comment.
Or is it unrelated?
Nothing,
okay. Yeah, no.
This has nothing to do with this question.
Yeah, okay. No, I think that we do a lot of multidisciplinary communication where, for instance, if you have a big project that requires different perspectives, you say, okay, you're from this field, you write that part. Then I will write this part, and then a third person will write the last part. And then we have an interdisciplinary report. But I don't think that actually works. So what I'm thinking is that as far as it goes now, we lack genuine interaction and collaboration between the fields. And it is also because, like you say, because of specialism. So that's the same in the hospital. If you have a chronic illness, then many things will be wrong with you. But the lung department is in a different hospital and the heart department is in a different part of the country. I mean, so it's, how can we say that it's integrated? And even what they do on the second floor, they don't know on the first floor because your data are protected. So it's really, really hard to have genuine collaboration across different, well, even sections.
It's probably more of a philosophical concept where you try to integrate knowledge. But nevertheless, I'll go to the next phase, and that is a little bit of a comment. And this has to do with what Dr. Junaid mentioned in his initial comments. And he said how presentations on philosophy are made as difficult as possible. And that has been my observation also, whereas when I've attended a lot of discussion groups. And since this is mostly a Muslim gathering, I think I can bring up this point that somehow philosophy amongst the grassroots Muslim level is extremely unpopular. And there are various reasons for that. There are various reasons for that. And one of the reasons is how difficult a presentation is made by using terminology like ontological approach, anthropomorphism. And I'm going to say that, Dr. Anjum, it's very commendable that you've made this presentation in as simple language as possible, without using the bombastic terminology of philosophy, which causes some of our grassroots level individual Muslims not only to hit the ceiling, but to leave the room. I appreciate that. That was my comment.
Oh, thank you so much. I mean, I sit at so many conferences in philosophy where I don't understand anything. And people use not only, I mean, ontology, epistemology, I'm guilty of trying to explain that to a lot of physiotherapists, but I really think that a lot of philosophers, they don't want to explain anything. They want to seem really smart. And if you want to seem really smart, then the best thing is that no one understands what you say. So it's a problem.
Rani, oh yeah, Rani, you can't go, please, without answering this question. You are the person who, I mean, so many people are asking this question, and you are the right person to answer this. Why did science take such long time to take off when Aristotle already had brought us back into this world, which the real world, and some kind of experimentation can also be associated to Aristotle. So why did it take such long time?
But did it take long time? I mean, it took long time before things came to the West. I mean, because history of science is written by the West, isn't it? So that there's a lot of information that was lost. I mean, even the vaccines, they came to Europe from Istanbul. It was used in the East, not the vaccine, inoculation, that they took a bacterium, they gave it to someone to make them immune to a disease. And I mean, it took a lot of work by actually some high-standing women in society to bring it to Europe and to promote it. And the Russian empress, she promoted it in Russia. But yeah, so I think a lot of history is written in a certain way from the Western perspective. And yeah, it is slow if you're going to ignore everything that happens elsewhere in the world. The experimental method, I mean, I shouldn't say that I know how to pronounce the name of this person, but let me see if I can find scientific methods, the name of the person who actually came up with the experimental method, because everyone says it's Galileo Galilei. But
yeah, I've been seeing this, more and more in recent books. This problem that you are, and they are becoming more inclusive. I mean, there are some, long ago there were some Muslim names also. I mean, I'm not trying to make it I don't want to put it like it's put in the subcontinent that in a way,
but it's important to remember. I mean,
yeah, exactly.
the Catholic Church was very strict on Aristotelian knowledge and insights. So, I mean, there was a lot of knowledge there already. It's just, are you allowed to make it heard?
But I will find those names for the students. They are Ibn Rushd and some other even before that there are some other. I won't bother you
No, but
with that. Yeah.
I can take another question while I'm looking for this also.
Okay. One question that's in my that was.
I see there are some hands. Did they ask their questions already?
No, but I don't think we have time. That's why I'm a bit shy. So, Rani, you talked about authority in science, and
I can say what his name is.
Yeah,
it
please.
Says Ibn al-Haytham.
Yeah, Ibn al-Haytham. Yeah.
Okay, so
exactly.
He lived in 965, and Galilei, he was born in 1564. And Ibn al-Haytham, he developed, he developed the experimental method in science. And he has written a lot where he explains it in detail. But when we learn about it, we say it was Galilei who introduced it. So you see, history, it just ignores a lot of knowledge that we used to have.
By the way, his name also skipped my mind, and I exactly used his name. And where I first heard of it was in a YouTube. There's a YouTuber. He's making a lot of videos about philosophy and all that.
Yeah, I think maybe that's why I heard of it, because I'm on Twitter and that's where I get my information.
That's useful. I think Rani, we should let you go. We can go on and on. Everybody's enjoying this, but unfortunately the time is over. And thank you
can have
so
me back
much
instead another time. And if you gather some questions, then we could always you could always send them to me. Well,
that's a very good offer.
Thank you for your kind invitation. And it seems to me, I haven't been able to talk and read the comments, but I saw a lot of very nice comments in the discussion. Maybe I just ignored the ones that were critical, but that's how things work.
Thank you so much, Rani, for being here and illuminating us with so many different areas of knowledge. I don't even have the time to make a proper farewell. So
no,
thank you very much.
I'll just hang up.
And I should also thank this platform provided by Al-mawrid Pakistan for having you here. And thank you, the participants, and you asked really good questions. Thanks for that also. So
thank you.
Bye-bye, everyone.
Thank you. Bye.